Now, let's talk about operators. What exactly is an operator? So, operator, I would say, is any symbol that performs certain type of operation. That operation could be arithmetic in nature, it could be binary in nature, doesn't matter. It performs some operation. Okay. And for doing some operation, it actually takes set of values as inputs. That value could be constants or variables. So either of them it could be. So this is called as operands. That means operator is nothing but which act on certain operands, and those operands are your constants or variables. Now, these are the different types of operators we have. Like we have relational, shift operators, arithmetic, unary, bitwise, logical, ternary, and assignment. What does it mean by unary operator? So unary operator means any operator that just works on one operand. It could be a constant, it could be a variable, it doesn't matter. Only one operand it will work. So what are the operands that can work like that? You have plus plus I, that's an unary operator. I plus plus, that plus plus is again unary operator. Let's say you want to say -1, that minus is an unary operator. And let's say you want to change the value of a boolean to true to false or false to true, you will negate it. That's again an unary operator. Like here in this case, if you see this a plus plus, this is unary, this is also unary, this is also unary, and this is also unary. So it has, if you observe, the one thing common is they all work on one particular operand. That is the important thing to grab here. And what this program does, it just takes the 50, first prints 50 value, then it increments, then it becomes 51 at this point. Then here you are incrementing it, then using it, that's where it becomes 52. Then after that, you are decrementing it. Before that, you are using the value, so it prints 52. Then you are decrementing it becomes 51. And again, before using, you are decrementing it, so it becomes 50. So that is what it is doing. It's a simple program just to manipulate the particular variable by incrementing or decrementing. Now, what are the different arithmetic operators we have? We have basically addition, subtraction, division, modulo, and multiplication. Now, if you see, this is the addition operator where it just adds 20 plus 5. It makes the addition. And this is the subtraction. This is multiplication where it will multiply 20 by 5. And this is your division. So in division, understand that it will give you the quotient part. If you generally do the division, you will get the quotient part, right? That quotient part is what it gives. That means 5, if you divide by 20, I think it goes by 4 times, right? That 4 times is what comes as division. And percentage is nothing but something which gives the remainder. That means 20 percentage 5, the remainder if you look at is 0. That is what it gives. So these are arithmetic operators because they moreover perform some kind of addition, subtraction, multiplication, all arithmetic related operations. Now what are shift operators? Shift operators are nothing but given a number, if they are able to shift or move the bits of a number to left or right, those are called shift operators. Okay, and Java have less than and greater than operators where it can do the shifting of left or right. So these are the operators available. You have less than left shift, greater than right shift, and you have unsigned right shift as well. So what really happens is, so this 20 will be converted into binary first, and after that the bits are moved, 2 bits are moved from the left hand side. Similarly on the right hand side. Okay, this is what happens. And whatever after moving the bits, whatever the value which comes, binary value, that binary value gets converted into decimal and shows up as yes. So here you see 20 less than 2, it actually moves 2 bits of it, and there will be a binary value coming out. That binary value converted to decimal is what is 80. Similarly, you can try for others, and when you do just a binary calculation, you can get these numbers altogether. Now, what are relational operations? Now, if you look at relational operators, any operator that is used to check if there is a relation between two operands, or if there is a particular checking to say whether there is any relation you can establish between any comparison. Sometimes relation operator is also called as comparison operator. Let's say A greater than B. You are checking is A value greater than B. Or I want to check if the weight of a one person is greater than another person. I want to check if this guy is smarter than another person. All this comparisons comes under relational operators. And we have a bunch of relational operators here, like equal to, not equal to, less than equal to, greater than, and greater than equal to. Everything helps you to just see or compare whether these two operands are equal or not equal, like that. And the result of always these relational operators will be Boolean in nature. When I say Boolean, either it will be true or false. And these will be mostly used in your if conditions, while loops, for loops, all that. Now coming to bitwise operators, like the name says bitwise, that means these operators work at the bit level. So let's take an example. If you take m1 equal to 60 and m2 equal to 13, so the binary value of m1 equal to 60 is this, the binary value of m2 equal to 13 is this. Now when you do ampersand, pipe or cap or tilde, these are all the bitwise operators. So what does ampersand do is, ampersand, the way it works is, it will check whether two bits are equal. Equal in the sense, it checks whether two bits are same and must be 1. So here understand that both the bits must be 1, then only the result will be 1 in the case of ampersand. Here if you look at 0 ampersand 1 is 0, whereas 0 ampersand 0 is 0 because both the bits must be 1. That is the rule and follows this ampersand. Whereas in this case 1 1 it is 1, 1 1 it is 1. So that's why you see here it is 1 1 and 0 0. So wherever the two bits are both 1, that is where this ampersand gives the answer as 1. Otherwise, it will be 0. Whereas in the case of R, it expects at least one of the value to be 1. In this case, if you see 0, 1, at least one of the value must be 1. Here in this case, it is just 1. So, and the other is 0. So even if 1 is there, even if 1 time 1 is there, it is fine for it. So it just prints 1. Whereas in the case, both are zeros, that's why it is giving answer as 0. Whereas in this case, both are 1, so it is giving 1. In this case, both are 1s, so it is giving 1. So this is how the result of R ampersand will come out. Similarly, this is exclusive R. You have to look at XR table to figure out how it works. But the same formula will happen where it checks. Whereas in the case of XR, what really happens is, it just checks whether the bits are similar or not. If the bits are same, it will give us 0. If the bits are dissimilar, then it will give us 1.